All right, so how do we solve for a missing side on a right triangle?
Pythagorean theorem.
The Pythagorean theorem. We're missing this side. We'll need it to do all of my trig ratios. Is this a leg or a hypotenuse?
Leg.
It's a leg. So we're going to take the other leg as well. 16 squared and add it to, we don't know, so what do we want to call it? X equals the hypotenuse squared, which here is 34. I've learned my limits this morning. Monday mornings are not my thing. 16 squared, I'm pretty sure is 256. Please check me.
Yes.
Okay. Oof. Forgot my square. All right, 34 squared is 1156.
Yeah.
Subtract 256. And x squared equals 900, yeah? All right, take the square root, and what does x equal? 30. So this missing side is 30. Then we're going to find sine, cosine, and tangent from what angle? Okay. All right, so what's my opposite? My opposite, yeah, 16. My hypotenuse? And then my adjacent. All right, so let's start with sine. Do I write sine equals? Everyone look up here, please. This class was the worst at doing it, so put down your pencil. You need to tell me what angle, or it will be wrong. Today especially, we're going to solve for the measure of an angle using what we're doing right now. You have to put a letter here. You cannot put sine of equals. If you typed in your calculator right now, hit sine. What is it put that? What comes right after the word sine? Parentheses. This means, hey, put an angle right here. You can't just say sine equals. It does not make any sense because sine is a ratio of opposite over hypotenuse. It's a number. All right, so sine from angle K equals my opposite over my hypotenuse. So what's my opposite? 16, my hypotenuse. Does this reduce? To 8 over 17. All right, then we move on to the next trig function, which would be cosine of K. Cosine is what side over what side? Adjacent over hypotenuse. Adjacent is? My hypotenuse is? What does this reduce to? 15 over 17. All right, we got one more, which would be tangent. Give me 2 seconds to find room. Tangent from K, tank, equals opposite over adjacent. So opposite is? My adjacent is? What does this reduce to? So these are literally what we're doing today. So I'm going to write it over here on the side so we can look back to it. Sine of K ended up equaling 8 over 17. Cosine of K equals 15 over 17. Tangent of K equals 8 over 15. We're going to use these later because guess what's missing in each of these equations? Because they all have equal signs. That makes it an equation. What does this letter represent? An angle. Any of these would help you solve for this missing angle. We're going to talk about it today. Before we do, we're going to review what we've done. Solve for the missing side lengths. So we're going to solve for both of them. So from 37 degrees, which side would we like to solve for first? Sure, let's solve for our opposite. And which side were we given? Hypotenuse. So which trig function are we going to use? Sine. From what angle? Q, which is 37. Equals the opposite over the hypotenuse. So the opposite, do we know it? No, so we could call it x over the hypotenuse, which is 22. All right, do I need to flip this? No, I could just multiply by 22. That's how it cancels on that side. Do not circle it when you've done it.
What are we running to?
To the nearest tenth. Do we all get the same answer? Did you times it by 22? Oh, so you're not plugging in sine of 22, you're plugging in 22 times sine of 37. There you go. What do we get? Rounding to the nearest tenth?
13.2.
Do we all agree? 13.2. So don't circle it, because we're missing two things, are we not? We're missing this side and this side, and it says solve for both the missing sides. So what was the name of this missing side?
X.
We named it X. We named it opposite. What's the name of this side? It's PR or RP. So PR equals 13.2. That is the final answer. You cannot put X because we're about to solve for another side using the letter X. What's the other side that's missing? The adjacent. So we're going to use the adjacent and the hypotenuse. Why are we going to use the hypotenuse and not the side we just found?
It might be wrong.
Because our answer might be wrong. 22 is definitely not wrong. It's still the hypotenuse. So which trig function, we're looking at the blue now, which trig function deals with the adjacent and hypotenuse?
Cosine.
Cosine. From what angle? 37. Equals the adjacent over the hypotenuse. So what is the adjacent? We don't know, so we can call it x over the hypotenuse, which is 22. Do I need to flip it?
No.
No, just multiply by 22. What do we get?
17.6.
All right, but we need to name it. So technically, what side was this? RQ equals 17.6. Because if you name both x, it's going to be wrong. So for those of you who struggle with circling their answers, make sure you write the correct name, the answer, circle your final answer, that kind of thing. So we're going to talk about solving right triangles. So you can flip to the next page if you so choose. To solve a right triangle, so I would write this down somewhere. To solve a right triangle means to find all unknown side lengths and angle measures. So to find all unknown side lengths and angle measures. I don't care where you write it. Find somewhere to write it. The directions on your quiz and test will say solve the right triangle. It won't say, hey, solve for every side, solve for every angle. You will just have to do it. And you can solve if you're given either of the following situations. This is the one we'll be dealing with today. If you're given two side lengths, you have everything you need to know to find every other missing piece. All the missing angles and the last missing side. If you're given one side length and one acute angle, like we've been doing, you could find all missing angles and all missing sides. So these are your two scenarios that you're given. All right, so today we're going to be given this scenario. You're given two side lengths, just like we were given. Like when we found sine of k equals 8 over 17. We knew all of the sides. Knowing the sides can find all of the angles. Okay? So we're going to use the inverse. So think about this before you get freaked out by the word inverse. If I put x plus 2 equals 5, how would you solve for x? Subtract 2. Because guess what? A plus and a minus, they're inverses of each other. Do we agree? So what's going to happen is you're going to be given something that looks like this. Sine of k equals 8 over 17. K is what's missing. K is what we don't know. So we're going to have to use the inverse of sine to solve for k, because we want to get rid of sine, so we have to use the inverse of sine, just like with every other algebra problem. This is actually 2 buttons on your calculator. All right, so before I tell you which 2 buttons, I want you to write down to find missing angles. So find some place and write it down. To find the missing angles, you will use the inverse. To find missing angles, you will use the inverse. And the inverse looks like this. So to find missing angles, you will always use the inverse. And it could look like tangent. It looks like to the -1, sine to the -1, cosine to the -1. It is super simple. It's literally 2 buttons on your calculator, and I'll show you where they are. But But you need to know, to find missing angles, you will always use the inverse. Direct your attention to your calculator. All right, so on your calculator, you'll see in the row of sine, cosine, and tangent, you'll see lettering up above it in whatever particular color your calculator has. It should say sine to the -1, cosine to the -1, tangent to the -1. Does everyone see it? Don't click it all at once. So here's how you access that. You would hit Shift, which I'm sure you can figure out, Shift, and then you would click the perspective button to get to that inverse. So here's what that means. If I were trying to find angle A, tangent of angle A equals x, then I would use tangent, the inverse of tangent. Tangent to the -1 of x equals angle A. Same thing with sine and cosine. This looks like gibberish to you until we do it together. So we're going to do these 3 examples. I'm going to ask that you actually write down what you're typing in your calculator, or you will not know what you're doing when you look back on this. So this first one says tangent of A equals 0.75. So here's what you're going to do. To find angle A, we need to get rid of tangent. What's the opposite of tangent? The inverse of tangent. So you're going to hit Shift Tangent. The opposite of tangent is the inverse of tangent. So it should look like this. Shift tangent, so tangent to the -1, of 0.75. And then you will hit equals. Round to the nearest says tenth.
36.
Do we all agree? 36.9 is correct. So pause for a second. This is the same thing as tangent of A equals, what is 0.75 as a fraction?
3/4.
3/4. So these two are equivalent to each other. So what we've been doing, so everyone direct their attention up here. What we've been doing with these, we're 2 buttons away from finding the measure of that particular angle. So for this one, sine of k equals 8/17, we would do shift sine, so sine to -1, of 8/17 and hit enter, and it would tell you the answer. So you've always been 1 step away from finding the measure of an angle. Now you just know the 2 buttons. For letter B, we're solving for angle B. Sine of B equals 0.87. So what is the opposite of sine? Sine to the -1, the inverse. So sine to the -1 of 0.87 is what you're going to type in. I would make sure you're writing down what you're doing so you remember later what you typed in. That's why I have it on the screen.
60.5.
I'm going to get there. Do we all get 60.5? All right, and the last, cosine of C equals a 0.15. So what do we type in? Yeah, cosine of -1. So you're going to do shift cosine of 0.15. And we get 81.4. So it says solve the right triangle. What does solve the right triangle mean? You wrote it down. Find all sides and angles. So all missing sides and all missing angles. So here's what I want you to write. Over on the side, what is the only side that's missing? The hypotenuse. What is the name of the hypotenuse?
DE.
DE. So you're going to write DE over here. And then you're going to find the 2 angles that are missing, which would be angle D and angle, I think it's E. Yeah, E. You write them off to the side because I'm grading 3 parts to each problem at times however many kids there are. It's a lot, so I need to look at a box. Do we understand each other that this is what I'm looking at? Okay. All right, so let's talk about this. How would I find a missing side if I'm given 2 other sides? The Pythagorean theorem. A squared plus B squared equals C squared. Am I missing a leg or a hypotenuse?
Hypotenuse.
Hypotenuse. So these 2 are the legs. So I'm going to do 20 squared plus 21 squared. Equals, I don't know. I'm still going to call it C. Because we're missing a couple things. If we keep using X, it's going to get a little confusing. So 20 squared is 400. 21 squared, I'm pretty sure it's 441, but please check because I've been wrong today. 441 equals C squared. All right, let's add them together. 400 and 441 makes 841. And then how do I finish solving for C? Take the square roots. So C equals 29. So DE equals 29. All right, we move on. Questions on how to find the missing side. All right, which angle would we like to solve for first? E, sure. Solve for angle E. So we want to label the sides like we've been doing. Label the sides that you were given. What kind of side is 20? Opposite. And what kind of side is 21?
Adjacent.
So which trig function deals with the opposite and the adjacent?
Tangent.
Tangent. Normally I'd write these on the side of the screen. Over here. But I'm recording. Don't know if y'all knew. Now you do. Tangent from what angle? E equals the opposite over the adjacent, which is 20 over 21. So we want to solve for angle E. How do we get rid of tangent? To the negative 1, the inverse. So you're going to hit shift tangent, and tangent to the negative 1 should pop up. And you'll type in 20 over 21. What do we get? Round it to the nearest tenth. Do we agree? 43 point what? All right, so 43.6. We put a box around it. Questions on how we found that angle?
I thought we were solving for E.
We did solve for E. Oh, sorry, I wrote in the wrong one. I told you. 43.6. That's why I keep you around, Jackson. Keep me on my toes. All right, let's solve for angle D. Angle D. So what will my opposite be? 21. And then what will 20 be? Adjacent. So which trig function am I going to use?
Tangent.
Tangent from what angle? D. Equals the opposite, which is 21, over the adjacent, which is 20. So how do I solve for angle D? The inverse. So shift tangent. Tangent to the negative 1 should pop up. Type in 21 over 20. It should be...
46.4.
Yeah. So 46.4. We're going to circle it. Box it in or whatever. So what is a way we could check our angles are correct?
Plug them in. Like add them up.
Add them up. What should they add up to?
180.
180. So you should add 43.6 and 46.4, and they should add up to 90 because 90 plus the 90 that's already in there is 180. So these two should add to 90. Here is my only thing. Some people hear that and they're like, oh, we could have subtracted our first answer from 90 to find the other one. Technically, yes. But if you were wrong the first time, you're going to be wrong the second time. I would instead use it as a way to check yourself. These two should add up to 90. If they do not, one of them is wrong. Okay? Questions on that? Okay. All right, let's start with the next one. All right, we're going to find GJ. We're also going to find the measure of angle G and the measure of angle H. So I'm going to write it up here. All right, so first thing we want to find, in no particular order, but we're going to find it, is GJ. How do I find a missing side when I'm given two other sides? The Pythagorean theorem. This time, am I missing a hypotenuse or a leg?
A leg.
A leg. So I'm going to call these A and B. My hypotenuse is always C. So I'm going to do 91 squared plus, I'm going to call it B squared, equals 109 squared, because this is the hypotenuse. What is 91 squared? 8281 plus B squared equals 109 squared, it's 11 something. 11,881. Subtract 8281. What do we get? Pretty sure it's 3,600. Is it? Take square root. B equals 60. So GJ is 60 degrees. Or not degrees, just 60. Questions on finding that missing side. All right, let's find all of our missing angles. Why is this class super boring? I just don't understand. We're just going to be boring the rest of the year? You want to pray about it, Kamari?
Do you want to pray that we be born?
No, I don't think we need prayer for that. I think it's already happening. This used to be a fun class. Just throwing it out there. All right. Which angle would we like to solve for? Sure, let's solve for G. We want to use the two sides that were given to us because we know they're not wrong. What kind of side is 91?
Opposite.
Opposite. And what kind of side is 109? So which trig function deals with those two? So sine from what angle? G equals the opposite, which is 91, over the hypotenuse, which is 109. How do I get rid of sine? The inverse. So shift sine will look like this. Round to the nearest tenth.
56.6.
So that means the measure of angle G is 56.6. I'm going to box it in. All right, now let's find the last angle, which would be H. Which one of these sides will change? Yeah, the opposite. What will the opposite now be? Adjacent, and the hypotenuse is still the hypotenuse. So which trig function deals with these two sides? Cosine. Cosine from angle H equals the adjacent over the hypotenuse. So the adjacent is 91, the hypotenuse is 109. We get rid of cosine with the inverse. Should be, what, 33.4? Okay. 33.4. That's it. This is the extent that we are learning today. We'll actually talk about this. We can talk about it now. So trigonometry helps us solve for missing sides and angles. This is at the bottom of your page. Here's the difference. You're going to be given a question like both of these on your test. These are questions you literally type into your calculator, and you move on. So in the first one, which I believe matches up with yours, sine of 33 degrees, you're given the angle. What is the angle in sine of 33? 33. You're missing the trig ratio. So when you hit enter, so let's type in sine of 33. When you hit enter, you should get a number that is less than 1, or pretty dang close to it. What do we get? 5, 4, we'll say 5. Whereas in the second example, this is what we've been doing today. What is 0.333 equivalent to as a fraction? What is it? 1/3. It's the same thing as 1/3. So this is the same thing as a fraction. So what is missing in this picture? The angle, because we're given the ratio. The ratio is 0.33333. Because 0.3333 is the same thing as 1/3. So how would we solve for the missing angle, or the missing angle? What would we do here? Nope. How do you divide by sign? You do the inverse. It's the same thing as we've been doing. So if you're given a problem that looks like this, sine of x equals 0.333, you're going to, I'm going to write it down here, x will equal sine to the -1 of 0.333. So this is when you would hit shift sine. And what do we get for this one? 19.5. This one would be degrees. So notice the very difference in answers. Okay, if you got a 0.545 on a test, that's a big deal, right? That'd be like a half a point on a test. And if you got a 20, it's still terrible, but a 20 is very different than 0.54. We agree? Just think about change. If you got 55 cents back, that's not really a big deal. But if you got $20 back, that's a pretty big deal, right? So notice the difference. Here, the ratio was missing, so it's going to be less than 1. Here, the angle was missing, and it'll be bigger than 1. It'll be any number between 1 and 90. All right? All right, so last thing we talk about. This you want to write down somewhere. I don't care where. These are your notes. It doesn't bother me where you write them, because it will come up in conversation. To find a side length, there were two options. One of them was to use the Pythagorean theorem, and one of them was to use a trig ratio. When we're solving for a missing side, when do we use the Pythagorean theorem?
There's one side missing.
When there's one side missing, which means you're given
Two.
two sides. So when you're given two sides, you will use the Pythagorean theorem to solve for the last side. And when do we use a trig ratio? What were we given when we use a trig ratio? A what? A side and angle. So it's different. Okay? So when you're given two sides and you're missing the last one, you use the Pythagorean theorem. When you're given a side and an angle, you'll use a trig ratio.